1965 Packard Bell 98C9, 98C10 chassis combination unit. And this was brought to me by the son of the original owner. His parents owned this set, and he used to sit in front of this and watch cartoons, and he'd like to see it work again. So we're going to go through sort of a restoration process on this. We'll do an analysis in this video and maybe power it up and do some testing, but I'd like to do maybe a series of videos getting the whole thing to work. Color TV, and then over here we have the, is it stereo? Doesn't boast it. I don't see it. Solid state. I could swear I saw tubes in it. Oh yeah, multiplex monitor right there. So it is stereo. So I'd like to get that going. Now this is about 3 to 4 years earlier than the Packard Bell test set that we have the ongoing running test with the hour meter. I think that's a 98C18. RCA's chassis designation was CTC, and RCA's first color chassis was a CTC17. Their first rectangular color chassis was a CTC17. CTC16 was a roundy. So this has the degaussing ICP button. Looks like it's got a lot of use on it. Fine tuning has been used a lot. You can see the wear marks. So this is basically a CTC, RCA CTC17 clone. This uses a lot of the circuits. Vertical, horizontal. I think the flyback is interchangeable. Yoke is interchangeable. Probably the vertical output. Same tubes. I think the color demodulation is a little different. But this is basically a CTC17. And Packard Bell's chassis designation was 98C. And I forget where it started, but it went all the way up into the 98C40s. Oh, phonograph, gramophone, record player, turntable. By Gerard. It looks like it still has a sharp thingy on it. A double-sided sharp thingy. So maybe we'll get this to work. I'm not big on restoring phonographs, but if the needle and cartridge are good, then we'll definitely play with it. Seems to still be pretty free. So got the 45 adapter. Here's the interlock plug for the set. Here's the back of it. And I want to cover this up because this has still got a valid name on it from the original buyer. Imagine that. Cat. Somebody engraved cat in it. Maybe the cat engraved that. Anyway, I was looking at these, and when he dropped it off, I asked him, how much damn service did this thing need? And he said, oh, the TV repairman was there all the time. That's why these things are so routed out. I mean, those things are worn out. So, yeah, Packard Bell needed a lot of service even when it was new. It's the model number 25 KC 2, it looks like. So it's been inside all its life. That's why it's not rusty and crusty. It's dusty. It does have a solid state amp, but the tuner is tube. I wonder if this is the tuner that uses 6GH8s and the AM bar antenna is just hanging there limp. That right there is probably the same vertical output as the CTC21 we worked on recently, or it's probably interchangeable. Oh, it's been replaced. It's a FNIRSI. The original one probably caught fire. Got our electrical tape wrapped focus coil. Definitely looks like it burnt in there at one time. This chassis hinges out, and if it's got some real deep problem, I might opt to take and put it on the jig. Although I don't think unlike RCA, the tuners are not convenient to remove. Well, anyway, we also got this low-cost oscilloscope that this company sent me to do a review on. And this looks kind of handy. 250 megahertz. Wonder what the star means. So 50 megahertz should be more than sufficient to cover most repairs or diagnostic needs on a TV like this. You know, you're going to mainly be doing with this, you're going to be doing mostly your horizontal circuit with this, and then maybe vertical, maybe the color demodulation, color oscillator, and possibly the audio, just using it to follow audio. Let's start by checking the CRT. Now, he did say that this set was in use 20 years ago. It was probably the last time it was used or turned on or worked, which would have been 2005, 2004. So the set worked from 1965 to 2004. No wonder why it had so many service calls. That's a long run for a TV. I'd be surprised if this was the original CRT. It's probably a crappy Dunbar. Dunbar was the remanufacturer here in LA. There's a tag right there. Let's see. Sylvania, all new. Wow. We might be happy here. Oh wait, what's all this? Let me make sure I got the right socket. believe it was socket number 3. Oh yeah, I got the wrong socket. All right, the right socket has been installed. Set cutoff. Oh boy, no? Oh boy, we have, this thing's like new. This CRT is great. This thing was probably just replaced within 5,000. It's probably only got 8,000 hours on it. With as strong as it is, let's see what we can do is start turning the voltage down and see, because I'm not even at a full 6.3. Let's go down to 4.7 and see what happens. This thing's in excellent shape. Tube is in excellent shape. Okay, so let's yank some of the heavy hitter tubes out here. We'll do the vertical. We'll do the horizontal. Try not to disturb the dust. That'll do that one. We'll get the damper. We could leave the damper. And we'll go with a dim bulb. We'll do a 60-watt bulb. He said he tried to power it up and it didn't do anything. So, could be the breakers blown, the power switch. Nothing. Where is the power switch here? Pull on volume. And that's looks like a correct statement. We have nothing here. We do have a circuit board, a circuit breaker. I don't know where the circuit breaker is in the circuit. A lot of times it's in the secondary of this transformer, not the plate, not the filaments. Interesting, it has a capacitor. Let's see, we need to beat on that. There it went. Well, it went temporarily. Try that again. You can see it sparking inside. Watch when I hit it here. Come on, work long enough just for me to... Oh, see the spark in there? Oh, I had it. Come on. There we go. Just had to hit it just, well, it's still arcing. Just going to let that sit for a minute and let the capacitors kind of reform. I probably should go get a bigger bulb. I'm not in my usual shop area right now. Yeah, I think we should try the little oscilloscope out. And look at the horizontal oscillator. I'm going to just let this reform for a little bit, let the capacitors reform. I think we should try this out and look at the control grid of the horizontal output tube and just see the horizontal oscillator, see how this thing works. These are really handy. These days it's really all about the kind of presentation when you open something. You know, if this was in here like that, it would be totally unacceptable. If it didn't have a QR code, it would be unacceptable. But hey, it comes with a book. Catalog. This is our little quality control thingy. My question is, does it come with probes? And what do we need to test the set? And it looks like it comes with two sets of probes. And it looks like it comes with whatever that is. And it looks like it comes with regular test leads. Ooh, this might do more than I thought it would do. Well, it looks like this thing is a voltmeter, amp meter too, because it's got milliamps, 10 amps common, and volts, diode, ohms, centigrade. Oh boy. This is LA, right? So we want to check Espanol. That was a little bit... Oh, what did I do? Don't tell me I checked Chinese. Crap. Oh, crap. Okay, so this thing will kind of do a little bit of everything. Because there are your two scope inputs. That is the DDS is this, which is like a signal generator, but it'll go up to 10 megahertz, and it'll do all these different waveforms, but I don't think it'll do like modulated, so you couldn't use this to align an AM radio. I'd have to verify that. Finally got it into English, so it'll do multimeter. This is kind of weird, isn't it? Ooh, look, it tells you what holes to use. Okay, well, this has been running for a while. Well, I've been fighting trying to get that thing into the right language. It's my fault. I think I need to go up in wattage on the light bulb because right now all the energy is being consumed by the... well, I should probably make sure the stereo's off, but I think all the energy... No, it's all being consumed by the TV. See if this works. Let's kill this. Yeah. Came on. It's dimming down. Loudness. Push stereo. Tape. Ooh, FM, AM.
Relevant Radio, 9:30 a.m. Are you here? Fast space, fact space.
It's not a matter of opinion, it is a matter of fact.
KABC, Los Angeles, Orange County, a Cumulus media station.
At least 7 people are dead after a severe storm struck the Houston area over the last couple of days. At least 4 died in the city on Thursday when a storm hit, including 2 by falling trees and 1 by a falling crane. 3 storm-related deaths were reported Friday night.
From its original draft will make it easy to identify.
You can hear it, but boy, talk about appropriate music. Wonder if there's an antenna on this. Is that the TV or the radio or both? This is the radio right here. Yeah, it looks like it's got its dipole hooked up. It's got an internal dipole right here. Well, FM performance, guess we could bypass this. It's all over there.
In THR Platinum. So talk a little bit about that, because that has been in the news and it's been disconcerting.
You got to get off the music. Although I love the music, I can't deal with it in the copyright department.
Hormones in the body is absolutely essential for survival. And the scary thing is, most people are not doing anything about it. Most people do not know this. She is responsible for producing cells and repairing cells in your body. It's what pregnant woman, the start of life, what happens when that HGH circulates when a woman is pregnant, and it produces those new cells that you're ready. Being all the new organs and but as we get older, after the body's fully grown, that starts to drop about 17% every 10 years. And by the time we're 6 years of age, we've lost about 80% of that human growth hormone. So the drop in age has been linked to a variety of.
Okay, well, I think that's working okay. Should we try the gramophone? Gramophone. Ooh, I even have some gramophones here that we could try listening to. Let me see what I got. Went to a human being going out of business sale called an estate sale. Oh, the Foggy Mountain Breakdown. We got to do a little bit of this. No, 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 Wasn't that supposed to drop when I did that? Well, I can hear it coming off of there, but we have nothing out of the amp. I mean, it is totally, totally quiet. And I wonder if somebody unplugged. Is this it right here? Well, that sort of did something. Wow, that is high fidelity, man. Yeah. Cartridge is dead. No Foggy Mountain breakdown. Cartridge is dead. This breaker is 7 amps, according to the schematic. And what we're going to do here is we have a meter to check cathode current on the horizontal output tube, and we have a cathode current test adapter. This basically breaks the cathode so you can insert the meter, but it's got this little tab right here. That tab is to connect the scope to look at the control grid drive. So we'll hook our little scope to that and see what it looks like. I got a 700 watt light bulb here. We're just going to go all the way with it. If any of the capacitors get hot or show any type of weakness, they're going to just get replaced. I'm not going to screw with that on this. See a bunch of service tags in here. That one's got a date of 82 on it. It might be worth pulling the chassis out to inspect it, but let's power it up and look at the horizontal output, see what happens. Charcoal filtered cigarette bunions. I got the tubes repopulated. I got the scope hooked up. I got it set to one channel. I don't know what the speed I want is yet. So we want 220 volt. I wonder if this thing displays the peak to peak. That's something nice that the other ones do. Okay, here we go. Oh, the circuit breaker just went up in smoke. But the light bulb's coming on there, so let's see what happens here. We should see this hit first. And there it did. And then we should see our current start to come up here. Okay, I need to try and speed this up a little bit. Okay, there's a learning curve to this, and I haven't learned it yet, but I'm getting there. I wish it would display the peak to peak. Maybe there's a setting in there to do that. But here's what it looks like, which looks about right. And we have basically no cathode current, which indicates a dead horizontal output tube. Okay, it's suddenly running away and the sound just stopped. And the light bulb's getting bright. We still have drive though. Well, we're like 5 minutes into this. And the light bulb is getting very bright. We got a lot of hum. Okay, well, there are a lot of options here that you can turn on. I found them. You can turn on all these different measurements on the scope. And I turned on peak to peak and frequency. So the frequency right now is 15.65 and the peak to peak is 15.31, but that's times 10, so it's 153. I'm going to bypass this. Now our high voltage is up to what it should be. Our cathode current, our peak to peak has come up to 180 something, which they said 220. I didn't calibrate any of the thing. I didn't calibrate the probes or the scope or anything. So this is just right out of the package. I hear the vertical. I've got a lot of hum. Where's the brightness? Oh, there you go. Wow, is that bright? The vertical is way off too. Vertical hold is here. Yeah, there it is. There's a lot missing, isn't there? Well, I gotta be honest, the more I play around with this thing, the more I fall in love. You can drag this around wherever you want and a lot of options here. We have a tube here that's not getting hot. Warm, 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 hot. Ah, shit! Damn, that was hot. That's a 6AQ5. That's supposed to be hot. That's the audio output tube. So why is it behaving like it's behaving? The tuner is completely dead here. Nothing from the tuner. Huh, interesting. Wow, look at this on the voltmeter setting. It actually does like a scope. Does like a visual pattern of the DC voltage. Which that's very interesting because that would be great for automotive. Okay, so here's measuring the drive with the meter. I like this little thing. I really like this little thing. Of course, it's switching too fast for it to pick it up. I like this thing. It's kind of an all-in-one. Let's recap on where we are right now. And I gotta say, this is really not fun to work on the floor. It's very tempting to get the chassis out and put it on the jig. We have a nice raster that looks very grayish white. We have no activity from the tuner. I did hear some humming from the audio in the beginning, but as soon as I moved the tubes, that kind of went away. It doesn't look like there's any severe hum in that, but it's really hard to tell. None of the filters are getting hot or even warm, so that's a good thing. After we run them a while, I would like to ESR test them and see where they are. This is IF123. IF123 color killer, second sound, second audio detector, audio output. So I don't understand. I guess I get a little scratchy there. I'm going to bypass the light bulb. But I get nothing here. You should get some scratchy from the volume control from the speakers. And these are, they're not, it's hard to tell if they have, that one right there is like cool. It's warm, but it's like it doesn't have any plate voltage. So we have no activity. We have sweep circuits and high voltage, but we don't have any activity from the RF side of this thing. When you move the tubes, there's always some staticky thing from the sockets. And this is stone quiet. So the audio amp is working. Well, this is their idea of a easy service chassis. The chassis opens up like this, and I'll tell you, this is not easy service. Something I want to show that's pretty interesting. These are customer claim checks, and there's two of them here, and this one is got a date of 1982, 7/29/1982. So there's two here. Looks like there was one here. 3, 4, possibly 5, 6, 7, 8, 9. What these are is these are when the shop would pull it out and take it into the shop and service it on a jig. So this chassis has been out and serviced at least 10 times. At least. Which sort of suggests that the Packard Bell test set that has kind of continuous problems was standard. So I think what I'm going to do, because this video is probably getting pretty long, let's go through and use our little all-in-one scope meter thing and check the voltages on some of the IF tubes. We can't get to the third IF tube because it's under this shield. And we'll go from there, but I think I'm going to end up pulling it out and taking it and putting it on a jig too, because it's certainly a lot easier to service when you can, you know, just look right at the back of it and then have the screen on the side of you. Here I can't see what's going on the front of it without looking at a mirror. Well, it looks like this comes off of here. At least they knew that their stuff was problematic and was going to need to be serviced a lot. So there's a couple different ways to go about this. You could, of course, pull all the tubes out and test them. You can start checking voltages on the tubes, which is what I'm going to do, or you could start with signal injection and inject the IF and start working your way third, second, first, and see where it drops out. But let's check a few voltages here. Ooh. I don't know what kind of thing is going on there, but that's pretty furry. Sort of like a combination of Zenith and RCA. It's RCA circuit design with Zenith construction. And these blue capacitors they use are excellent. These ones right here, that say Packard Bell made in US, they are excellent capacitors. That looks like that's been changed. I know you can't even see any color because of all the dust. Get it fired up. On the first IF, we should have 180 on 5, 180 on 6, and 20 volts on 2. Come on, it's not that hard. There we go. There we go. Well, we got right on 180 on 6, 180 on 5. Well, if that's correct, we got 1 volt on the cathode, which is way low. Let's go to the second IF here. We should have 360 on 5, 360 on 6. We'll start there. Well, we got 319 on 6 and 319 on 5. Listen to that car alarm for a minute. Well, we have on the cathode, which is 2, we have one, it says 195, we have 180. Okay, let's take a look at the third here. So 210 on 7, 210 on 8. Okay, 210, 210, and then 2.5 on the cathode. So we got 205 there, 205 there, and we have 1.1 volt on the cathode, which would suggest another weak tube. I checked the voltages on these pins, the TV sound IF amp 6GH8. And I'm going to put the meter on pin 2 here and listen. Pin 2 was this one. K and X. So the signal is definitely coming through the sound chain. Yeah, that's the audio output. That's the detector. That's the sound IF. And that's the first sound IF. And we definitely have activity to here. So the signal starts here, first video IF, second video IF, third video IF. This is both sound and video. Then from here it splits off to the sound and the video. And so I did hear a little something there. I do hear a little something there. Well, these tubes look like they're weak. With the higher plate voltage and the lower cathode voltage, that's a weak tube. It's conducting less. But is it going to cause the thing to be stone dead the way it is? I'm going to bypass this. Yeah, I think it's time to get it out and put it on I think it's time to get it out and put it on the jig. Kneeling over is very uncomfortable and kind of unwarranted. I do like this little meter. They did send it to me to review in this video. I kind of recommend it. I think it would be a great companion in working on TVs for someone who didn't have a whole lot of test equipment. The only thing I wish it had was the ability to do some modulation on the signal generator part. I mean, if it could, we could put it at 4.5 megahertz, put a little modulation on it, and run it into the audio on this thing. So that's one thing they should add, and I think software would do that. I mean, if it's just a microprocessor generated deal, I don't see why software wouldn't do that. So add that into this little 1 kilohertz AM or FM modulation on your signal generator. Anyway, I'll put a link to that in the valley below. This is the AGC. Before I totally yank the chassis, I'm going to try and turn this a little bit. Oh, wow. Wow, well that made a bit of a difference, didn't it? I think the AGC pot was just dirty and kind of in a dead spot. Okay, I'm going to put this back on and we'll get the generator and see how this thing works, if it actually works. All right. I got the VG91 hooked up to it, and for some reason it seems like it's quiet again. I got the VG91 hooked up to it on channel 3. I think I'm going to bypass the light bulb here. What's interesting is it's gone quiet again. That's sort of interesting. I'm going to turn the AGC pot. Maybe there's a problem there. Yeah, interesting. Now it's gone completely dead quiet again. And well, the sound has. Let's see, vertical, where are you? Picture fidelity, vertical hold. Wow, look at that. The vertical controls are adjusted properly. Will it do color? That is the question. And what happened here. We have issues. That's blasting 5 volts of RF into it. I'm going to turn the AGC again. I'm going to go down to 2.5 volts on the RF. Thought I saw some color there. I'm looking at the camera screen. We've got AGC problems here. But there's color. Picture fidelity, tone, color level. I am going to turn the AGC again. Well, this thing has some interesting behavioral traits, doesn't it? Put it on split field. There's an ANI control too, which I believe is like automatic noise something or another. Turn the AGC again. That's bringing the generator down to 2.5 volts. RF. So something in the AGC is cutting the front end off, and it's a keyed AGC, which there's probably a capacitor in there that's at fault, or a tube. Yeah, there's no adjustability to the AGC. That's like from there to there is like a quarter, 1 o'clock, one hour of turn on the pot. From there to there is like 15 or 20 degrees, if that. And then look at the frickin' noise in it. This is a weird one. It's a weird one. It has a lot of promise, a lot of potential, but it's a weird one. I think I'm gonna wrap it up right here, and we'll do a part 2 on this. I gotta sit down and study the schematic and decide what I want to do, how I want to go about this thing. What if I go back down to reduced voltage? That's does nothing. Yeah, I gotta think about this. Do I want to pull the chassis and put it on the jig, or what do I want to do? You really don't see a whole lot of problems with the AGC. Man, what kind of clinky dink. This is a weird one. This is a real weird one. What the? What the hell is that? That's adjusting the RF level right there. The AGC is not working at all, and it's causing it to overload. That's turning the sound off. The sound is clearly getting into the video real bad. Wow, it sort of acts totally different without the sound. How does a mixer oscillator tube have a short in it? try channel 4. Let me see if I can go right into the IF. See if I can unplug the tuner and go right into the IF and eliminate the tuner. Okay, what I did there is I just wrapped the lead around the first IF tube, and I'm going into IF. What a bunch of garbage. I'm going to turn the AGC. I can. Boy, man. We're so right there. It's just you turn it and it's like 5 degrees and it goes, you see it work for a second and then stop working. Yeah, it's got an IF problem, IF AGC problem, bad tube, bad capacitor, something's bad. Okay, I'm gonna say part 1. Let me deal with the circuit breaker, figure out if I want to get it on the jig, and we'll do part 2.